Does the series converge or diverge? Well, since the section is called the integral test, I guess I'll try that. So we have this function. One thing you need to verify is that it's going to be getting smaller and smaller and smaller and smaller and smaller until it becomes 0. Because if the individual values themselves don't become 0, if they leveled off, let's say, at a height of 1, then that means you'd be adding up 1 plus 1 plus 1 plus 1 plus 1, it equals infinity. Well, with this one, the limit as n goes to infinity of the individual terms so when you've got n going to infinity, then n squared is going to control the whole thing. N is not powerful enough to overpower n squared. So you're going to get the same answer as when you just take the most powerful term. Then 1 divided by infinity will give you 0. So it passes that. Now the next thing is we need to be able to integrate. So integrate from 2 to infinity 1 over n squared minus n. And then how do you integrate that? Well, notice that it can be factored. So if it can be factored, we're going to be using integration by parts. So I'm going to work over here to do the algebra. 1 over, and then factor it, n times n minus 1. So that's going to be something over n plus something over n minus 1. So then you multiply through by the n times n minus 1, or the least common denominator. You'll get 1 equals a times n minus 1 plus b times n. And then you can pick things for n like n equals 0. That will zero this out. That will give you that a is going to be a negative 1. Next, let n say equal 1. That will make this disappear. And then we'd have 1 equals b times 1. So there's the b. So we are integrating the a, which is negative 1 over n, plus the b, from 2 to infinity. So this is going to be negative the natural log of n, plus this one is going to be the natural log of n minus 1. And then, well, this is basically saying negative natural log plus positive natural log. Are they going to cancel each other out? Well, if these things go to infinity, the answer is we really don't know. If they're just numbers, then they can cancel each other out. So let's see. We've got n going to infinity, so this is natural log of infinity plus the natural log of infinity. Now, it seems that those are going to cancel because it looks like they're the same thing, but you've got to be careful with infinity arithmetic. We're going to have to investigate that and see if they cancel. And then substitute a 2. So minus negative the natural log of 2 plus the natural log of 2 minus 1. So there we go. And then natural log of 1 is 0. So is it possible that the answer is going to be just a positive natural log of 2? So this. So then how could we verify do these cancel? So we could look at it graphically. So this is going to be the negative natural log of x function, and this will be the natural log of x minus 1 function. So the negative natural log of x function plus the natural log of x minus 1 function. It looks like they're canceling each other out. It sure does. So if we have the window and x is supposed to go to infinity, so let's go out to 100, and then I think the answer is going to be 0, so narrow down the y's. Then the function, yeah, that looks like it's going to 0. Trace some numerical evidence. Alright, so it does seem that these are going to cancel each other out. This was equal to 0, so it's gone. And so we get that the answer is just going to be a negative negative, or in other words, natural log of 2, which is 0.693. I just want to double check quickly by using the sum sequence. So if we do sum sequence, the function is 1 divided by x squared minus x, so I'm going back to the original before I did anything to it, with x going from 2 to, and then pick a big number, let's try 100. Is the answer close to 0.693? Okay, that's for 100. Don't worry. How about for 200? Seems like it got bigger. How about 500? Seems like the answer is 1. Give us another try. How about 1,000? Come on, calculator. It seems like the answer is 1. I've got another way to check. It's 1 divided by x squared minus x. And then take a look at the graph for that. And then ask the calculator to integrate that from 2 to say 50. 0.673. That's closer to what I got. And then integrate from 2 to 100. I think this goes to 100. 683. So it's getting closer to what I said, 693. So I guess when I did that sum sequence, perhaps I typed something in wrong. Alright, I'm convinced 693 is it. This is beautiful calculus.